Hello again, everybody. This is Mr. Reeves back with you as we continue to work our way through the Math 8 CAASPP Practice Test. And we are now on number 23. Problem number 23 says Jamal states that ax plus b equals a times the quantity of x plus c, given a, b, and c are not equal to 0. What must be the value of c for Jamal's statement to be true? All right, so when you look at this, hopefully, immediately you think of the distributive property. The distributive property says if you have a number, or in this case, a variable, outside a quantity, inside where you have either a sum or a difference, the distributive property of multiplication over addition and subtraction says you can multiply this on the outside by what's on the inside. So first thing I'm going to do is a times x, and that's going to give me ax. And then I'm going to multiply a times c, and that's going to give me ac. So this side right here is equal to that. So if we rewrite what we had, Jamal's statement on the left side is ax plus b, and Jamal's statement on the right side is ax plus ac. And of course, this right here says these two are equal. Now, ax will always be equal to ax. So the question now becomes, what do we need to do to make b equal to ac, or more specifically, what is the value of c? So when you have an equation and you want to find the value of the variable, you solve for that variable by using inverse operations. So since I have a times c and I want to get c by itself, I'm going to go ahead and divide both sides by a. A divided by a is 1, and when I do that, I get b divided by a is equal to c. So if we want to make Jamal's statement correct, b divided by a equals c, or c equals b divided by a. So there we go. That's the answer to number 23. All right, moving on to number 24. A cylinder with a radius 3 feet and a height of 5 feet is shown. Enter the volume of the cylinder in cubic feet. Round your answer to the nearest hundredth. All right, so right here, the distance from the center to any point on the circle, that is the radius. And they told us that the radius is equal to 3 feet. And the height of a cylinder is the distance between the bases. So we want to go from the top base to the bottom base, and that height is 5 feet. So it says enter the volume, which means we need to know the formula for the volume of a cylinder. Well, the volume of any prism is base times height, the area of the base times the height, and a cylinder is simply a circular prism. So the volume of a cylinder is the area of the base. But what is this base? What shape is it? And we've got another one down here. I could try to sketch it in there. And right there, this would be our other base, and it would have the same radius right there. So that is a circle, right? And the area of a circle is pi r squared. So the volume of a cylinder is pi r squared times the height, which is h. So now we just need to fill in those. Pi is a constant. We don't need to fill in anything for pi. The radius they told us is 3, and the height they told us is 5. So if we follow order of operations, we'll do exponents first. So we get pi times 9 times 5. Or if we rearrange this, 9 times 5 is 45. So the volume would be 45 pi cubic feet. Cubic feet. Don't know what I was thinking. Feet cubed, cubic feet. All right, so luckily over here, they have allowed us to use a calculator. So I'm going to go ahead and pull up the calculator. I'm going to pull up the calculator. I think I'm going to pull up the calculator. There it is. Don't know why it's being so difficult. And I'm going to do 45 times, and I'm looking for pi right there. There's pi, so we're just going to put in pi, and we get 141.371669.4, but it says to round our answer to the nearest hundredth. Well, the nearest hundredth is going to be two places. So I go 1 to the right, and it's a 1, which means it's going to be 141.37. 141.37. And it is in cubic feet, but again, I've said this multiple times during this test. If they give you the units in the question, you do not need to put the units in the answer. So 141.37 cubic feet is the volume of a cylinder with a radius of 3 feet and a height of 5 feet. All right, onward. Number 25. All right, select all the equations that can be represented by a straight line when graphed on the coordinate plane. All right, so when they talk about a straight line, and they're talking about an equation that makes a straight line, so what we're looking for is a linear equation. Now, there's different forms of linear equations that you should have studied. There is the most common one, which is slope-intercept form, which is y equals mx plus b. There's also another form called standard form, which is capital AX plus capital BY equals capital C. And you may also have studied point slope form, which is y minus y1 equals m times the quantity of x minus x1. And these are all types of linear equations. And if you look at what they have in common, they have an x and a y, an x and a y, an x and a y with no exponents, and they're not in the numerator. So when you are looking to see if an equation, and they've given us all these equations and they want to know which are linear, you want to look for an equation that has a y and an x with no exponents, and the y and the x are not in the denominator. Or another way to say that is, can you take the equation and rewrite it to look like one of these? Most commonly, again, slope-intercept form is the one we deal with the most, especially in 8th grade. Y equals mx plus b. All right, so if we take a look at this first one, it looks promising. We have a y and we have an x, but take a look at where that x is. That x is down in the denominator, and we're not allowed to have that down in the denominator in a linear equation. So this one is going to be a no. All right, if you take a look at this one right here, the second choice, there's our x and there's our y. There's no exponents. And if I wanted to, I could get this y by itself by subtracting 16 and dividing by 3. And I could write it as y equals mx plus b. So this one's going to be a yes. All right, well, what do you notice about number 3, or choice number 3? Do you see that right there? It has an exponent on the y. Immediately when you see an exponent on the x or a y, that tells you it is not linear. So this one's going to be a no. All right, this one right here looks a lot like this, doesn't it? In standard form, except it has a subtraction instead of addition. Again, I could solve this for y by subtracting 8x and then dividing by -5. This one's going to be a yes. All right, in the previous problem, we talked about the distributive property. I could go ahead and distribute here, and then it would be y equals mx plus b. That's going to be a yes. Now, what's going to happen here? This one I also could distribute. If I distribute x times 3, I get 3x. Not a problem yet. But what is x times x? X times x is x to the second power. And then what do we have right there? We have an exponent on the x. And again, if you have an exponent on either the y or the x, then that is not linear. All right? So we've got no, yes, yes, no. or in other words, that's 1 and those 2 are yeses, and the other 3s were no. All right, that takes care of question number 25. How about question number 26? The graph x plus y equals -9 is shown. So this is the graph of x plus y equals -9. Use the add arrow to graph the equation y equals 2x plus 3 on the same coordinate plane. Then use the add point tool to plot the solution to this system of linear equations. All right, so they have already graphed x plus y equals -9. That right there, that line shows all of the solutions to that equation. All right, so we don't have to worry about that. They did that for us. Now they're asking us to take a look at this equation. Y equals 2x plus 3. Well, just like in the previous problem we were talking about, y equals mx plus b. That is an equation in slope intercept form. And hopefully you remember m is the slope and b is the y intercept. So if I were asked to graph a line in y equals mx plus b or slope intercept form, what we need to do is we start with the y-intercept, which if we take a look over here, the y-intercept is 3, and then we use the slope to get more points. Because if you want to draw a line, you have to have points, and you have to have a minimum of 2 points. So that slope, which they gave us here as 2, or if we want it as a fraction, 2 over 1, that's how we're going to graph this line. So we're going to go ahead and start at 3. So we're going to go right up here and we're going to start at 3. That's the y-intercept. And then the slope is the rise over the run. The rise over the run, or the change in y, or the change in x, or the vertical change over the horizontal change. And since they're both positive, and this has a positive slope, I'm going to go up 2 and write 1. And officially, that's enough points to make my line, but really it's a better idea to keep going up 2, write 1, up 2, write 1. And since we ran out of space, instead of going up and right, we could work our way backwards, down and left, down and left, and we could keep going that way. All right, so we're going to do that with the add arrow, right? We're going to go ahead and go start at 3 and then use the slope of 2 over 1, and then we're going to see where they actually cross. So here we go. So I'm going to start at 3, and I could go up 2 and over 1, and 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 there would be my line, right? All right, but I'm looking for an intersection point here, and as you can see, my red line isn't going to reach, at least not the way I've written it. Lines go on forever, and that's what those arrows mean. So I'm going to go ahead and keep going here. So just like I said, I could go down 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. I'll do it one more time. Down 2 and over 1. And you can see now that that line extends, and now I can find this point of intersection. So I'm going to go ahead and choose add point, and I'm going to put it right there, right where they intersect. So the point of intersection is at -4, -5. -4, -5. Let me try that again. The x value is -4, and the y value is -5. And you know what the great thing about solving a system of equations is? You could always check your answer, right? Our first equation, the one that they took care of for us, was x plus y equals -9. Well, if I plug in the x value of -4 and the y value of -5, what do I get? -4 plus -5 is -9. It works. And if I go to the second equation, the one that we actually had to graph, and again, I'm going to put -5 in for y, and I'm going to put -4 in for x, what do I get? I get -5 equals -8 plus 3. And is that true? 8 negatives plus 3 positives, does that equal -5? Guess what? it does. So that proves that our solution was actually the correct one. -4 and -5. All right, so I think we're good. Next question, question 27. I think this is the last one in this video, right? Yeah. All right, here we go. A biologist tracks the number of bacteria living in a water tank. It's a pleasant thought. The biologist used a function that represents the amount of a certain chemical solution. Sorry, let me try reading that again. The biologist used a function that represents the amount of a certain chemical solution that is added to the water. When the water has no chemicals, the number of bacteria is 1,200 per gallon. For each tablespoon of the chemical solution C that is added to each gallon of water, the number of bacteria decreases by 75 per gallon. So every tablespoon we add of this chemical, for each gallon we have, the bacteria goes down by 75 per gallon. That's a mouthful, wow. How much of the chemical in tablespoons must be added to a 500-gallon tank to reduce the bacteria count to a safe 300 bacteria per gallon? Wow, that's a lot of words to put together. So let's take a look at this and break it down. First of all, we have a 500-gallon tank. So I'm just going to make a sketch here. All right, and our tank contains 500 gallons. And when it starts, it has 1,200, 1,200 bacteria per gallon, right? So we have 500 gallons at 1,200 bacteria per gallon. When we are done, what do we want to have? When we are done, we are still going to have 500 gallons, right? But instead of 1,200 bacteria per gallon, we only want what? 300 bacteria per gallon, right? So what has to happen? We have to go down, right? We have to go down 900 bacteria per gallon. That's our goal. We need to go down 900 bacteria per gallon. All right, so how are we going to do that? We're not going to do that by getting rid of water. We're going to do that by getting rid of bacteria. And how do we get rid of bacteria? It says for each tablespoon added to each gallon of water, the number of bacteria decreases by 75 per gallon. So every time we add one of these tablespoons, it goes down by 75 per gallon. All right, so how many do we need to go down? We need to go down 900. So we need to go down 900 bacteria. And we're going to do it in steps of what? In steps of 75, right? So now we need to go down 900, and we're going to do it in steps of 75. So 900 bacteria divided by 75 bacteria per teaspoon. That will tell us how many teaspoons we need to reduce 900 bacteria. And again, remember, this is what? This is per gallon, right? All right, so I'm going to go ahead and go to my calculator, and I'm going to do 900 divided by 75. 900 divided by 75. And what do I get? I get 12. All right, so 900 divided by 75 means I need 12 what? 12 teaspoons per gallon. 12 teaspoons per gallon. But my tank isn't 1 gallon. My tank is what? 500 gallons. So if we want to go down 900 bacteria per gallon, we need 12 teaspoons per gallon. But how many gallons do we have? How many gallons do we have? We have 500. So I need to do 500 gallons times 12 teaspoons per gallon. So again, I'm going to go back to my calculator and I'm going to do 500. I'm going to clear it all out and I'm going to do 500 times 12 and I get 6,000. So the answer that I need is 6,000 it's tablespoons. I'm sorry. I've been saying teaspoons. It's tablespoons. 6,000 tablespoons is what we need. But again, the units are in the question, so we don't have to put the units in the answer. But 6,000 tablespoons is what it would take to get that level of bacteria down to a safe level of 300 bacteria per gallon for all 500 gallons. And that's the end of this video. We have just one more video to go and we will have finished the grade 8 CAASPP practice test. Thanks for watching.